Yeah, ne? Hey guys, hello. So, yeah. I don't know. It's been a long time coming, this thing of me at least showing, a bit of ingenuity. So, what's happening today is that I am trying to see if having a scenario like this will be of help in any way. Maybe have a difference. You know what I mean? Yeah. Hello, who knows? Who knows? Otherwise, how is everybody doing today? I hope we are good. Hope we are well. Hope we are grooving. Okay, so what grades do we have up in here? 80 people. We're always wondering if we can answer any important questions that people have. Just let me know just let me know. I see someone that shared the live. The question is, as you sharing the live, what grade are you in and what is cooking, guys? We are starting a new week. If people have any special requests, they must come in through and request what they want to request. Let's see. See if you guys can see that 1 plus 1 is equal to okay, very good. Tando 13, 2, that's true. That's very true. That's very true. It's very true. Okay, beautiful. Minus 5 plus 3 is equal to? We're just testing the new board, guys. Just testing it. Just testing to see how people comma mx3. Right, guys, when you respond, right, with your answer, please respond and then let me know what grade you are in next to your response. Don't just respond. Respond with your answer and then write the grade that you are in next to your response, okay? So you guys are 100% correct. That's -5 plus 3 is -2. You guys are 100% correct. Okay, nice. Let's check this out. Oh, Tando is in grade 11. Okay, so currently, if Tando is in grade 11, then Tando, what topic are you guys currently busy with at school at the moment? One over 2 plus 1 over 3, step by step, is, I don't want the answer. I want how do we go about answering the question. 1 over 2 plus 1 over 3. Akama is in grade 10. Okay. One over 2 plus 1 over 3. Do we understand the step-by-step process to getting to the answer? Okay, I see cross multiply. All right, let's do this then. Yeah, let's see. Because you're saying we must 1 over 2 plus 1 over 3 minus 1 over 4. How's about that? Step by step, what do we do? Answering a question like this. 1 over 2 plus 1 over 3 minus 1 over 4, step by step. What is the first step to adding and subtracting fractions? What must first happen? Okay, very good. Akama MX3 says we need to first find the LCD. Guys, very important. Okay? Yeah. The thing is, 2, 3, and 4 have different denominators. You cannot add fractions until your denominators are the same. Now, to make your denominators the same, we use the concept of LCM. And so we find the LCM of 3, 4, and 2. All right? But because these numbers, 2, 3, and 4, are in the denominator, we say we are going to find the LCD, okay, which is the lowest common denominator. So between 2, 3, and 4, right, the multiples of 2, we have 2, 4, 6, 8, 10, 12. Multiples of 3, 3, 6, 9, 12. Nearly we want to say maybe the lowest common multiple is 6, because so far what's common between 2 and 3 with the multiples is 6. But then if we include the multiples of 4, we have 4, 8. Now 8 and 8 are common for 2 and 4, but then obviously for 3 it's a bit of a problem. So what we do find is that the lowest common multiple between 2, 3, and 4 is actually 12. All right. Then because we know what the LCD is now, that it is 12, right? We know that the LCD is 12. Okay. We're able to find that out quite nicely and easily. What we then do is we form equivalent fractions using the LCD. Okay, what are equivalent fractions? What do we mean by forming equivalent fractions using the LCD? We are going to take 1 over 2 and we are going to ask ourselves, what must I multiply 2 with in order to get the LCD, which is 12? What can I multiply 2 with to get 12? Or in other words, what is 12 divided by 2? That's another way of looking at it. What is 12 divided by 2? So 12 times what gives me 12? Yes, a comma. It's 6, right? So we multiply by 6. But what we do in the denominator, we do in the numerator. Do you see? So 1 over 2 becomes 1 times 6. 2 times 6. It becomes 6 over 12. So 1 over 2 has an equivalent fraction, which is 6 over 12 when the denominator is 12, when the LCD is 12. We do the same thing with 1 over 3. What can we multiply 3 with to get 12? Or in other words, what is 12 divided by 3? Then we'll get the number that we need to multiply by 3 to get 12. Yeah, a comma, very good. We multiply by 4 in the denominator. What we do in the denominator, we do where? In the numerator. We multiply by 4. So then that means we are going to get 1 times 4 is 4. 3 times 4 is 12. Then we move on to negative 1 over 4. We do the same thing. What number can we multiply by 4 to get 12? Or in other words, what is 12 divided by 4? What's the number that you can multiply by 4 to get 12? Or in other words, what is 12 divided by 4 if we are looking at a different sort of like way? 4 times what gives you 12? Or in other words, what is 12 divided by 4? Yes, a comma. We times by 3, right? 4 times 3 gives you 12. But what we do in the denominator, we do up there in the numerator. So we get, now the rule says when the denominators are the same, when adding and subtracting fractions, we keep the denominator as it is, then we add and subtract the numerators. So now that the denominators are the same, we can freely say 6 plus 4 is what? Minus 3. What's 6 plus 4? Minus 3. 6 plus 4 is 10. Then what's 10 minus 3? It is 7. So our answer is 7 over 12. And that is how, guys, we add and subtract fractions. Okay, so please, it is that simple to add and subtract fractions. Okay, it is that simple. And this skill of adding and subtracting fractions step by step is important, because when we get to fractions in grade 10 and we are dealing with algebraic fractions where there are variables, we still use the same principle to add and subtract fractions. So it's important to understand these basics. Okay. So I hope we are good. All right. But Karma, since you've been so kind in answering questions in the comment section, right? In your grade 10, what is it that you'd like us to look at? What specific aspect of something that you have done or are doing would you like to look at right now? Okay, here's a question, random. Okay, here's a question there. If 5 cos A plus 3 is equal to 0 and the A is greater than 180 but less than 360, use a diagram to find sine 90 minus A and 2 tan squared A. So if you are in grade 10, you should be able to answer a question like this. Okay, which topic is this? Trigonometry. So the question is saying if 5 cos A plus 3 is equal to 0 and A is between, or in other words, A is greater than 180 but less than 360, use the diagram or use a diagram, don't use a calculator, to find sine 90 minus A and B 2 tan squared A. So how do we answer questions of this nature? How do we go about it? How do we go about such a question? If 5 cos A plus 3 is equal to 0 and A is between 180 and 360, use the diagram to find sine 90 minus A and then B 2 tan squared. Okay, so guys, there's a few steps that we need to make sure that we are aware of when answering such questions. Okay, if you're a grade 10 learner, you've done trigonometry, you should be able to answer this question, but if you're not, then here is something to be mindful of. So step 1. Step 1, we are going to refer to this right there, the 5 cos A plus 3 is equal to 0. And what we are going to do there is we are going to isolate the trig ratio. We are going to isolate the trig ratio. So you look at the equation, you isolate the trig ratio. All right. So that means we take 5 cos A, we transpose the plus 3. Okay? So we take the plus 3 to the other side. get 5 cos A is equal to negative 3. Then we divide both sides by the coefficient. Divide both sides by the coefficient. We get cos A is equal to negative 3 over 5. Okay. Now, two things that we can conclude from the fact that cos A is equal to negative 3 over 5. One, cos is negative. Where do we get that? From the sign. Okay. 2, the definition of cos is adjacent over hypotenuse. So these are two important things that we learn from having isolated the trig ratio. Okay? These are important things. So from isolating the trig ratio, we get to know what the sign of the trig ratio is. That's the first thing. Secondly, we get to know what the definition of the trig ratio is. Step 2, we come now to our restriction. The restriction of the angle A and in which quadrant that covers. Okay. So when we say 180 to 360, please understand this, that in your Cartesian plane, you have 0, 90, 180, 270, and back there 360. We are moving in an anti-clockwise direction, right? So that means to say A lies between 180 and 360. This is our first quadrant, second quadrant, third quadrant, fourth quadrant. Okay. So what we are going to do is we are going to identify the quadrants, okay, as per first the fact that cos is negative. Where is cos negative on the Cartesian plane? To further guide us about that, there is what we call the ASTC rule. This ASTC rule helps us with knowing that here, all our trig ratios, sine, cos, and tan, are all positive. This second quadrant, we know that only sine and its reciprocal cosec are positive. Here, we know that only tan is positive and its reciprocal cot. And then here we know that only cos is positive and it's a reciprocal sec. All trig ratios are positive in the first quadrant. Sine, cos, tan, and all in the reciprocals. Here, second quadrant, sine is positive, meaning all other trig ratios, all right, are negative. So cos and tan are negative here. Here, tan and its reciprocal cot are positive, all other trig ratios are negative. And here, cos is positive with its reciprocal sec, and all other trig ratios are negative. Very important to know. Okay, so we call it the ASTC. All students take care or all students take chemistry. I dare not say all students take caffeine, coke, and all the other substances. Okay, so to remember, all students take chemistry, or at least all students take care. Okay, so we are now going to identify which quadrant all students take coffee. Well, all students do take coffee, especially when they want to burn the midnight oil and they want to stay up and not sleep, right? But it's not healthy, guys. It's not healthy. All students take care. All right, let's take care. Let's take care of ourselves. All right. So remember, the first thing we did is we isolated the trig ratio cos, and then we learned two things. One, cos is negative. That's the first thing we learned. Two, we learned the definition of cos then would be adjacent over hypotenuse. Alright, so guys, sorry, those two things, cos is negative. Alright, so the two things that are important then for the identification of our angle in the correct quadrant is knowing, one, what is the sign of the trig ratio? Two, what is the restriction? So those are the two things we are going to use to tick our quadrants. And the quadrant where the ticks are intersecting or the ticks are overlapping, that is the quadrant where we are going to sketch our diagram that we are going to use to find these trig expressions. Okay. So first and foremost, we learned that cos is negative. The question is, where is cos negative? According to ASTC, where is cos going to be negative? Is cos going to be negative in this quadrant, the first quadrant? Definitely not, because all trig ratios are positive here. Is cos going to be negative in the second quadrant? Is cos going to be negative in the second quadrant, guys? Is this where cos is negative? Is cos going to be negative here in the third quadrant? Okay, so Tando is saying yes, cos is negative in the second quadrant. Is cos negative in the third quadrant? Okay. So according to this, we know that sine is positive here and it's reciprocal cosec, which means all other trig ratios are negative. Is cos going to be negative in the third quadrant? Yes, definitely. Cos is going to be negative in the third quadrant. Okay. So that means we have two quadrants where cos is negative, the second and the third quadrant. Okay. Then we are done with our ticks where cos is negative. We then go to our restriction. The angle A lies between 180 and 360. In other words, A is greater than 180 but less than 360. So if that is the case, which quadrants does that cover between 180 and 360? Remember, this is 180, that's all the way to 270, then to 360. So which quadrants are those? It's the third and the fourth quadrant. So we are ticking this quadrant the second time, so there's an overlap there. And then the fourth quadrant, of course. So that means our diagram is going to lie where? It is going to lie in the third quadrant. So what we do is we draw what we call a terminal arm. All right. we draw a terminal arm in that quadrant. Then we complete a 90-degree angle triangle for that terminal arm. We draw a terminal arm in the third quadrant. Then we complete that terminal arm by sketching a right angle triangle. Okay. Now, A is the angle that is acute. So we are going to label the angle A, which is acute in that quadrant. Okay. Then, of course, we know that, the terminal arm is lying in the third quadrant. Okay, so we have 90, we have angle A, we then include a third angle, which is going to be 90 minus whatever that acute angle is. So since it's angle A, we're going to say 90 minus A. If it was angle theta, we would say 90 minus theta. If it was angle beta, we would say 90 minus beta. Okay. Why is it specifically going to be 90 minus A, this angle specifically? It's because we need to, when we add all three of these angles, they need to add up to what? Sum. When we add those three angles, they need to add up to what, since it's a triangle? When we add those angles in a triangle, they need to add up to what when we add them together? Okay, so they obviously need to add up to 180 degrees. So if you think about it, a 90 plus this 90 gives you 180. And then an A minus A gives you 0. So that 180 degrees actually holds for those three angles. Okay, now we are not done. We then go back to our trig ratio, this one. Remember, this was cos A is equal to negative 3 over 5. And then we know that A is the angle, but then we are saying cos of angle A is equal to negative 3 over 5. The definition of cos is adjacent over hypotenuse. So that means this is the angle A. The adjacent side of this angle is going to be negative 3, which is basically what this point is. X here is negative 3. So I basically then appoint negative 3 for this coordinate on this horizontal x-axis. X here is negative 3 for the x-axis. So that's the adjacent side. The hypotenuse side is going to be 5. The hypotenuse of our right angle triangle on our Cartesian plane is always positive. Okay. Now we need to know what this side is of the triangle. So to find that side, guys, of the triangle, the missing side, what can we use for our right angle triangle to find the missing, sorry, not the missing side really, but the missing coordinate on the y-axis? What do we use? What can we do to find the missing y value? We have the x value, we have the hypotenuse, which is the r value. What can we do to find the missing y value? Yes, Tando, we can use Pythagoras theorem, right? Okay, so Pythagoras theorem. So if you will allow me, just want to remove this here. think we've seen the question at least, so that I can go ahead and use Pythagoras. So I'm going to say the square of the hypotenuse is equal to the sum of the square of the other two sides. So r squared is equal to x squared plus y squared. R squared is equal to x squared plus y squared. R squared is equal to x squared plus y squared. Now remember, our r value, our hypotenuse, is 5 squared. Our value of x is -3. We want y squared. We want y. So basically we are going to be interested in finding that y value. 5 squared, 25. -3 squared is 9. That is y squared. Then we go ahead and we find the value of y. Take the 9, transpose it, we isolate the y squared. Okay. Then of course we can say our y squared is equal to 16. We take the square root on both sides. When we do so in an equation, we take the square root on both sides in an equation, we make sure we put plus minus, the square root of plus minus 16. Okay. Then of course that gives me y is equal to plus minus 4. But of course, in that diagram of ours, our y value, if you look at the y value guys there, in that quadrant, the y value is supposed to be, is it supposed to be positive or negative guys, the y value in that quadrant? Okay, is the y value supposed to be positive or negative? Because now I need to make the choice. My two values of y, there I have them. It can either be positive or negative, but in the third quadrant, what is the condition of my y value in the third quadrant? Exactly, Tabza. It's negative. Thank you so much. So here, I've completed my diagram. My diagram is now complete. It can be used. All right. My diagram is complete. I have the -3 for my value of x in the x-axis, my y value, which is negative for the y-axis, and then my hypotenuse, which is 5. All angles as well, 90, angle A, and 90 minus A. All those angles are accounted for. Now I can answer, guys, the questions that were asked of me. The first one was they wanted me to find the sine of 90 minus A. So I can remove everything now that I have here. Take it down. Let's remove everything so that I can now answer the questions. Okay. Can remove everything. Just gonna redraw that diagram. Okay. Just gonna redraw it. Okay. Just redraw it. Okay. -4, -3, +5. My acute angle A, 90 minus A, this angle. So now I can find, using this diagram, I'm going to find sine of 90 minus A. Now, sine of 90 minus A, guys, remember to get the sine of 90 minus a. I'm going to read from my diagram. So where is 90 minus a? That's the question you ask. Where is this 90 minus a? It's this angle here. Okay, 90 minus a is this angle here. Then what is the definition of sine in reference to this angle? Sine is opposite SOH, which is SOH. SOH means opposite over hypotenuse. So where is my opposite side for this angle 90 minus a? Not for the angle a, but for 90 minus a. Where is my opposite side? My opposite side for 90 minus a is negative 3. So I'm going to say negative 3. That's the opposite side of 90 minus a. We are not talking about the opposite side of angle A. We are talking about the opposite side of 90 minus a, since here it says sine of 90 minus a. So this is your angle that you are referring to. You look at it and then you ask yourself, which side is opposite 90 minus a? It's this one. Okay. Then what is the hypotenuse side for the same angle? Obviously the hypotenuse stays the same. It is going to be 5. So guys, that is basically the replacement of sine of 90 minus a. It's negative 3 over 5. Okay, so sine of 90 minus a is negative 3 over 5. B, 2 tan, but they're saying squared a. So the first thing we're going to do is we are actually going to put a bracket around tan of a, and then the square we are going to put outside of the trig ratio, because that's the meaning of 2 tan squared a. The exponent 2 applies to the trig ratio, not to the coefficient. Or it applies, this square applies to the trig ratio, not to the coefficient. So the 2 is still isolated. All right. Then the tan squared a, that tan squared, the exponent you put external to the trig ratio so that you can do your substitution of the ratio from the diagram. So we are going to say, what is tan of angle A? So angle A is this one. So now we are no longer looking at this guy here. We are looking at that guy there. Angle A is that one. So then we are going to use this as a reference and read what the tan of angle A is. So the tan of angle A is here. Tan is TOA, meaning opposite over adjacent. So what is the opposite side of angle A? It is the opposite side of angle A. So I'm going to write 2 brackets tan opposite negative 4 over adjacent, the adjacent side of angle A. Thank you, Tabza. Negative 3. Then you apply the square. Okay. So guys, the ratio negative 4 over negative 3 completely replaces tan of A, because this represents tan of angle A, negative 4 over negative 3. Now you can apply BODMAS, simplify and get the answer. Right. So obviously the exponent gets priority into the bracket because BODMAS says so. Brackets, O meaning order, means exponents and roots. So the 2 will get multiplied to what? 16 over 9. Now 2 times 16 over 9 will give you what? It will give you 32 over 9. That is the answer. So that is basically the value, not 32 over 18. Be very careful. This 2 is a numerator value. Okay. Remember that 2 is the same thing as 2 over 1. Okay. Just be careful with that. So the 2 doesn't get multiplied to the numerator and get multiplied to the denominator. No. This is one term. So you multiply the numerator with the numerator. 2 times 16 is 32. You multiply the denominator with the denominator. 1 times 9 is actually 9. Okay. So be very careful there. Otherwise, that's how we go about answering questions of that nature. Okay. Hopefully that's clear. We've all understood, and I can take off this particular problem. Okay. Any other questions of another nature? He comes down. Okay. Want to do one last one with these. Okay. Here's another. So this one is saying if 4 tan b minus 3 is equal to 0 and cos b is less than 0, use a diagram to find sin b plus cos b, the whole thing squared. Okay. So what are our thoughts here? There we go, nice. Nice. Okay. Tando there is doing the most. Okay, so first things first, we learned from last time that we isolate. What do we isolate? We focus on the trig ratio, we isolate the trig ratio. Right, isolate it. Then we get 2 pieces of information after isolating the trig ratio. The sign of the trig ratio and the definition of the trig ratio. Okay, and that's very important. Okay, so hopefully you guys have gotten that sorted by now. Okay, so if we take negative 3 over, we get for tan b is equal to 3. We divide both sides by 4. Then we get tan b is equal to 3 over 4. Okay, we know that means opposite over adjacent, and we also learn that tan is what? Based on the value of 3 over 4. We learn that tan is actually positive. Okay, so that's sorted piece of information because we isolated the trig ratio. 2. We come here to get the second piece of information for our ticking. So our ticks will come from this, and our ticks will come from that, because this is the restriction. So let's go there to our quadrant. Remember the ASTC. It's going to help us at the end to locate the appropriate quadrant, locate the correct quadrant where we should sketch our diagram, because that will be where B, the angle, will lie, and its terminal arm. So from here, tan is positive. Where is tan positive, guys? Which quadrants is tan positive? Sorry, mistake there. ASTC. I forgot that all students take care. So where is tan positive? Starting here. Where is tan positive, guys? Which quadrants is tan positive? Tan is positive in which quadrants? Yes, Buddha. First and third. Very good. First and third. Just for people's information, this is the first quadrant, second quadrant, third quadrant, fourth quadrant. Just so you know. Okay. First, second, third, fourth. In an anti-clockwise direction, first, second, third, fourth. So our first quadrant is where tan is positive. So we are positive here, and we are positive there. Okay, we are done with these ticks. Then we go to this. Cos B is less than 0. What does this mean? If something is less than 0, we mean that that thing is actually what? Okay. We mean it is negative, right? Something is less than 0, it means it's negative. So that means cos is negative. So our question then is, where is cos going to be negative? Because that's where we are going to tick next. Where is cos negative? Is it in the first quadrant, second quadrant, third quadrant, or fourth quadrant? Where exactly is cos going to be negative? Okay, cos is negative in the second and the fourth quadrant. Second and fourth. Is it? Okay, third, sorry. Z is saying second and fourth. Changed her mind there. Third. So which one are we fixing? So which two then are we accepting? Okay, so cos is negative in the second and the third. Do we all agree? Second and third. That's where cos is negative, second and third. Are we in agreement? Okay, second and third. Okay, there we go. So second and third. Second and third. So there we have it. Second and third. So our drawing then, you can see where the ticks overlap. We are actually in this quadrant, which is great. That's where the ticks overlap. So that means when we draw, we are going to draw a terminal arm in the third quadrant again. We complete 90-degree. B, we write there, and then we write this as 90 minus B. We're very deliberate and intentional. That's 90, that's B, that's 90 minus B. It's always 90 minus the acute angle. Okay. Nonchalant Dre, what's up? So our angles are all in there. Now we need to make sure our sides, or at least the coordinates for each point, X, Y, and R, are also there. So if we look at the definition of tan B, it's 3/4, which is opposite over adjacent. So that means B, here's B, the opposite side of B, okay, is 3. But we know that in the y-axis, the 3 has to be negative. All right, so we make sure that that 3 is negative in that quadrant. Then adjacent side of B is this here. The x value on this side, the x coordinate, is negative. So that's why our x value then is negative. And maybe you are wondering why then is 3/4 actually positive? Because guys, remember, a negative divided by another negative, what does it give you? A positive. So that's why 3/4 finds itself being positive ultimately. Then we need to find R. So we are going to use what to find R? We are going to use what to find R? As usual, to find the missing value of R, we use our friend, Mr. Who? Yes, Buddha 45, Mr. Pythagoras. So let's go ahead and use Mr. Pythagoras. R squared is equal to x squared plus y squared. We Pythagoras it up. That is -4 the whole thing squared, -3 the whole thing squared, 16 plus 9, which is 25. Okay, very good. It's 25. Okay, then after getting that 25, we know that we conclude by taking what on either side. We know most, we take r squared, we take the square root on both sides, put plus minus. So obviously taking the square root means r is equal to plus or minus 5, but we know our r value can never be negative. R is always positive, not negative, guys. Here's the thing, R is always positive. The only values that change according to our quadrants are x and y, but R in all quadrants is always positive, okay? Doesn't matter what quadrant we are in, R is always positive. The only value that changes is x and y depending on which quadrant we are in. So if our diagram was in this first quadrant, y and x are both positive in the first quadrant. R, like I said, is always positive. If we're in this quadrant, the x is negative, the y is positive. If we are in this quadrant, the x is negative, the y is positive. If we're in this quadrant, the y is negative, the x is positive. So let's always remember that, my good people. Once we know those things, makes life such a beautiful thing. All right, so r is 5. Diagram is complete. We have all sides and all angles. Now we can come and answer the question, which was to find the value of sine b plus cos b using the diagram. Okay. So all we do is we just write sine b plus cos b, and then we square. We go to the diagram. And we basically read from the diagram what sine b is. B is here. The definition of sine is opposite over hypotenuse, -3/5. So all we do is we simply go there and we write -3/5 plus cos b. Go to the diagram again. Here's b. Cos b is adjacent over hypotenuse. So obviously the b angle, -4/5. Okay. Then just want to remove this, guys, if you don't mind. Hope you guys got that whole Pythagoras reason, of course. -3. We just simply say -3/5. The positive times the negative, guys. What does a positive times the negative give me? And -4/5. Then inside, the denominators are already the same, so I can just keep the denominator, add and subtract the numerators. -3 minus 4 is -7. But then remember, I have to square it. So that means my answer is 49, because if you square 7, you get 49. The negative also gets squared, it becomes positive. You square 5, you get 25. So our answer is 49/25. Okay. I hope we are having fun with this. It's making sense. Okay. Any questions that people have? Any questions at all? Any questions at all? Okay, so it's clear, eh? Yeah, I'm glad. If it's clear, then I'm happy. I'm happy, guys. I'm happy for you. Let's continue being happy people. Let's continue being happy people. What did you miss? You missed the beginning. Are you gonna post it on YouTube? Of course, but like, it's pretty much, I was doing the same questions. It was me answering questions of this nature. So I would say you didn't miss much. Miss much. Okay. Well, guys, thank you so much. Thank you so much. Thank you so much. yeah, hope you take care. Unless there's other questions before I bounce off of here. If not, then shalom shaloms. Okay, unless there's questions that people have, I'm happy to take any questions if there are any. I'm happy to take any questions if there are any. Any particular questions? Any questions at all, or no questions, or anything that people would like to. Good evening, Sechame. It's a good evening to you. No questions. No questions. So no one has any questions. Okay. I guess as there's no questions. Let me take down. I'm late. Yeah, well, kind of. Kinda. Was kinda. Thank you so much for the hot meat, by the way. As late as you are. As late as you are. As late as you are. So no one has any questions for me, guys? No questions at all? Anyone? Olan is one. Guys, I'm willing to take any requests. If you have any requests, anything that you'd like to actually go over right now, You can type it in the comment section, or you can come up, you can request. I'll take your invite and see what we can do with your request, if you have any. Let's take some requests now, guys. I think me is open to that. Any requests from people? Algebra, what aspect of algebra? Okay, there we go. Zwane, Mr. Zwane. Solve for x and y specifically. Okay, let's look at solve for x and y specifically. Okay, and I'm guessing you're probably in another grade as well. Okay, there we go. 6 marks. 6 marks up for grabs. Solve for x and y. This is a grade. So this is grade 11 and 12 specifically. Okay. But if you are in grade 10, yeah, have a throw at it if you want. So line is one, this is yours. You said you wanted simultaneous, so here it is. Solve the following, solve for x and y, the question would say. So you have a equation, the first one being a linear kind of equation, where x and y have the exponent that is invisible, which is 1. So that says that that's a linear equation. The second equation is a quadratic type because the highest exponent for any variable is 2. So if you have two equations like that, you take the linear one and you make either x or y the subject. Advised is to make x the subject, but it's fine, you could also make y the subject. It's just that if you make x the subject, you avoid working with fractions. If you make y the subject, then you do not avoid having fractions in your equation. So if I am someone who's doing this question, I would easily make x the subject rather than make y the subject of the equation. But really depends on who you are, right? So to make x the subject, then it's going to be x is equal to we take the 3 and the 2y over. Negative 3 becomes positive 3. Positive 2y becomes negative 2y. Then we say this is equation 3. Because remember, this is initially equation 1, and then this is initially equation 2. But then we take the linear one, and we make x or y the subject, and then we call it equation 3. Make sense? Yeah. Now, after making x the subject, that means where x is in this equation, we are going to substitute in brackets the expression 3 minus 2y. Where x is, we are going to substitute the expression 3 minus 2y in the other equation. So in this equation, where x is, we are substituting 3 minus 2y. So that x followed by an exponent, this would be where the x would be. We are substituting it in brackets, the exponent minus 2, where x is 3 minus 2y followed by y minus 4y is equal to 0. Your mark allocation so far would be, you would get a mark here for making x or y the subject for the linear equation. Your second mark allocation would be substituting in the place of x the expression 3 minus 2y. Alright, that would be your mark allocation 2. Now then, you now have to expand, multiply out, and then get your equation into what we call standard form. So when you have an addition or a subtraction between two terms, what we do is we square the first term, you get 9. You square the last term, which is negative 2y, you get positive 4y squared. You multiply these two together. 3 times negative 2y gives you negative 6y. Then you double it. So that negative 6y becomes negative 12y. This is a shortcut. When you have an expression of 2 terms inside the bracket and it's squared, you square the first term, you get that. You square the last term with its sign, you get that last term. Then you multiply these two and then you double what you get. So 3 times negative 2y is negative 6y. Negative 6y times 2, you get negative 12y. Alright, shortcut. Then, here's something to note. This negative 2 and this y. Alright, remember these are 1, 2, 3, they are all multiplied. Brackets in maths mean multiply. So this negative 2 and this y, I would rather you write the y next to the 2. Because remember, multiplication is commutative. In other words, the order in which you place the 2 with the bracket with the y doesn't really matter. So if I decide to take the y that was there and bring it closer to the 2, negative 2 times y times this is still the same thing. It still produces the same answer. Multiplication is commutative. That way you take the negative 2y, you distribute it to the 2 terms. And it's easier that way, you know. Because sometimes when you have the y that side, some people forget to get the y inside the bracket. Does that make sense? So then you get negative 6y. Negative times a positive is a negative. 2 times 3 is 6. Y next door. Negative times a negative is a positive. 2 times 2 is 4. Y times y. You keep the base, laws of exponents. 3 times 3 is 6. 4 times 4 is 9. 4 times 4 is 16. 16 times 4 is 24. 24 times 4 is 36. 36 times 4 is 96. 96 times 4 is 120. 120 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 times 4 is 120. Laws of exponents say if you are multiplying same bases, you keep the base, you add them exponents. So y times y is going to give me y squared, because 1 plus 1 is 2. Snoko. We've been Taiva Snoko. We've been doing that. Ulama moto all the time. Shai moto. We've been sharing the motto all the time, bro. Sharing the motto all the time. Then it's a matter now of actually writing our equation in standard form. How? We write our equation in descending powers of y. By that we mean the square term first, followed by the y term, followed by the constant term that has no variable. So 4y squared plus 4y squared will give you 8y squared. We are done with these friends. Negative 12y minus 6y, that's negative 18. Then negative 18 minus 4. Negative 22y. Now at this stage, most people would use the quadratic formula, which is fine. Okay, I am not against that notion. If you want, go ahead and use the quadratic formula, have fun. Okay, I'm really not against it, not in the slightest bit. So yeah, some people use quadratic formula, some people would factorize, some people would use maybe varying methods, but at the end of the day, what we do want to have is we want to have the factors. Okay, right, so if you want to use a quadratic formula, go ahead. Just make sure when you use that quadratic formula, you don't say x is equal to, because remember your equation is in terms of y. So you want to say y is equal to minus b plus minus the square root of b squared minus 4ac over 2a if you use the quadratic formula. So be mindful of the variable, right? So you're going to say y is equal to if you use the quadratic formula. Okay, you can definitely do that. Okay. So let's try something out here. If we decided to open two brackets and play Mr. Trial and Error method, just checking something out here. Just checking something out here. So positive means same signs according to who? According to the sign of the middle term. So we're just checking something out there, right? 4y minus 9 into 2y minus 1. Now multiplying this and that does give me that. Multiplying this and that does give me that. The multiplication of this gives me negative 18y. The multiplication of that and that gives me negative 4y. And the addition of that does give me this. So this works. Okay, so that means the factors correct. that's fine. Like I said, if you use the quadratic formula, that's fine. Just make sure you make y the subject of the equation. Okay. Then okay, that's the y values. Then we must not think we are done here. Remember, we should never think we are done just because we got the y values. Because sometimes, many times, learners stop right there and they forget that they are actually solving for x and y. So now let's finish it off. We take this y value, come and substitute right here. This was waiting for x to be solved. Taking the y values and substituting them there. 2 into half. X is 2. Four. 2 times 9 over 4. 2 goes into 4 2 times. So we have 9 over 2. Then of course we are going to get negative 3. So y values 9 over 4.5. Then our x values are negative 3 over 2 and 2. Okay. That is that. Solving simultaneously. Okay. So hopefully that helps my man there that asked about solving. Golan is one. Solving x and y. That was it. Okay, that was it. That is how we go about it. Solving for x and for y. Thanks, and can you do the one with square roots and exponents? Okay, I'm not so sure what you mean. Do you mean third equations? Or do you mean solving for x and y where there's exponents? So are you asking me to do third equations? Or are you asking me to do third equations in one instance and then in another instance a simultaneous equation that has exponents in the mix? Just trying to understand you. So let me know. Solving x and y with this exponents. Okay, I'll do that now, just now. Let's take this down. Let's take this down. Okay, there we go. So there's a question that is simultaneous, but it involves a bit of exponential, it has a bit of an exponential touch if you want. So you have two equations there. 3 to the power y plus 1 is equal to 9 to the power x, and then you have x squared minus xy plus y squared is equal to 7. So you have to solve those two equations simultaneously, right? So 3 to the power y plus 1 is an exponential equation, and then you can see it has a bit of what you could say a linear equation touch. Yes, VMAPs, very good. Make the bases to be the same. Very good, VMAPs. So the quadratic equation is one that is always untouched, but the exponential equation would have to manipulate and touch because it can be manipulated in such a way that it can lead us to a linear equation. So we're going to take equation 1 and write 9 as 3 to the power 2. That basically is 3 to the power y plus 1 is equal to 3 to the power 2x. Bases are the same on either side of the equal sign. Bases are the same. We can then drop the bases and equate them exponents. Now we can make y the subject and then say that's equation 3. I think from there you should be able to move in a direction that will lead you somewhere. You get the point. So now we actually do now have a linear equation, right? Y is the subject. We've deliberately made y the subject because the coefficient of y is basically 1, all right? Now you can take that equation 3, you see? Exactly VMAPs. Now we substitute, right? We substitute. So that means where y is in equation 2, we substitute in brackets 2x minus 1. So where y is, we are going to substitute 2x minus 1 in brackets. So we rewrite this, but just with a little bit of a touch. Okay, that's not y, so we write the x squared as it is, minus x. Now here, y, 2x minus 1. There's no exponent, plus the y, 2x minus 1. We square it. Equal to 7. I then from there I can then go ahead. This x squared, take the negative x, distribute it, negative 2x squared plus x. This here, you remember the method I said we can apply when there are two terms inside the bracket, there's a plus and a minus sign. It's very basic. We square the first term, so that means we square the number and the variable, we get 4x squared. We square the last term, plus 1. We multiply these two, 2x times negative 1. That gives us negative 2x. Then we double it, so that's negative 4x. Take the 7, transpose it, equal to 0. Right. Then this plus sign, basically when we distribute that plus sign, positive times positive is positive, it doesn't change any of the terms. So we can just remove the bracket because the plus sign does not change any of the terms. But if there was a minus sign, we would distribute that minus sign. We would have that bracket there as usual, but distributed the sign to all the terms so that we can see truly what the equation has, for us. Now we can add like terms. X squared minus 2x squared is negative x squared, plus 4x squared is negative, no, it's not negative. X squared plus 4x squared is 5x squared. 5x squared minus 2x is 3x squared. Done. X minus 4x is negative 3x. 1 minus 7, negative 6. As the highest common factor, it's a numerical value. So when the highest common factor, guys, is a numerical value, you can divide. You can literally go ahead and divide by the coefficient. But if it was a variable, if the highest common factor had a variable, we would take out that common factor, not divide by it throughout the equation. So the reason why we're going to divide by the highest common factor and get x squared minus x minus 2 is equal to 0 is because we want to simplify our equation in the standard form. Okay. Then we can now factorize. Coefficient of x squared is 1, so that allows us to open two brackets. The negative sign means we are going to have different signs inside the bracket, but the highest factor is going to be negative. Different signs inside the bracket, positive and negative, but the highest factor of 2 is going to have a negative sign. 2 is a prime number, so its factors are 2 and 1. The highest number is 2, so it will have the negative sign. Then we can quickly check something here very quickly. What is a negative 2 times a positive 1? It gives you negative 2. When you add negative 2 and 1, you get negative 1, which is the coefficient of x. So this works. You put an x and an x. So that's our factors. Okay. That is our factors. At this point, if you want a screenshot, you should have screenshot already. Okay, because what I want to do now is I just want to go and rub out what we have there at the top so that I can prepare to basically conclude this problem in style. Now let's conclude the problem in style. Okay. The x minus 2, you apply the 0 factor law. So x is equal to 2 or x is equal to negative 1. x minus 2 equal to 0, or x plus 1 equal to 0. This negative 2, transpose it, x is equal to 2, or x is equal to negative 1. Okay. Makes sense? Then we can now take our x values, come back to equation 3. Y is waiting for x. Y is equal to 2 into 2 minus 1, or y is equal to 2 into negative 1 minus 1. So that's 4 minus 1, which is 3. This side, y is equal to negative 2 minus 1. 2 times negative 1 is negative 2, which is negative 3. So we can write our answers. X is 2 whilst y is 3, or x is negative 1 whilst y is negative 3. Remember that your x and your y value that you get, that's actually your point of intersection of two functions that you basically had. So that concludes the solving for x and y. So hopefully that answers that young man's question well asked. I will call you young man, but I know you're probably not a young man. Okay, guys, do we have any other questions now? Any other? Yeah, so that way we know we are helping specific needs, we are addressing needs. Okay, so there's no other questions. No other questions. Okay. Okay, if there are no other questions, then VMAPs, no other questions. Kolanizwa, no other questions. Mataba, no other questions. Waititando, Karen, Pate, no other. Sekhavit, no other questions. I'm in bed watching. I want to rewrite my subjects, maths and physics. You're in bed, moment. Events. Having the time of your life in bed, aren't you? Yeah. Come up with one and let's do it. Yeah, I saw your ... But like, yeah, that's the only thing I've seen. As far as your comments, there's no other comment. Why would your comments not be showing anyways? I don't know why. If you've commented beyond that, then hey, they're not showing. I see the one where it says, are my comments not showing? But that's literally it. Why do you want to rewrite your maths and science VMAPs? Okay, here's one that Ulan is always coming. If tan 37 is equal to P, determine the following in terms. Determine if tan 37 is equal to P, determine the following in terms of P. So we want to determine psi of 127. Okay, so I've just added another question in what we need to determine. Okay, Kobulani's one is asking this question, and this is a question not in algebra anymore, but we have switched very quickly, all right, to trigonometry, as per Mr. Kobulani's one's request. Right, so what's beautiful, or what we need to make sure that we do here, is we need to firstly look at the if part, this part. Right, this question is no different from the ones where we were looking at your Pythagoras type questions. Those Pythagoras type questions need either we can draw our diagram on the Cartesian plane. So in this instance, we are actually going to just use Cartesian plane. Okay. I'm not playing Mr. Integral. Not in this space, because remember, me is specifically helping high school students, right? So integrals, I'm not going to be dealing with integrals. Yeah, I don't deal with them in this space. Yeah, wait for me in the day when I actually decide that I actually want to attack varsity mathematics, and it's, you know, Maths 1, Maths 2, Maths 3, then I'll start jumping into this space. So unfortunately, integrals, I'm not playing there yet, but will at some future point in time. But it's just that, you know, my heart is in high school. You'll figure it out. I'm sure you will. It's not difficult, by the way. It's quite straightforward. Yeah, it's just that I don't deal with them in this space. Okay, if tan 37 is equal to P, determine the following in terms of P. Okay. So firstly, we write down tan 37 degrees, and then we write it as P over 1. That tells us a few things. P, obviously the definition is opposite over adjacent. So we can intentionally decide that we are going to draw a diagram with a terminal arm in the first quadrant. Why specifically in the first quadrant? Because we are taking it that P, we have not been told anything else. No restrictions. There's no interval where the angle 37 degrees lies. But because we know 37 degrees is an acute angle, we're just simply going to write We are going to draw the diagram in the first quadrant. Okay. We are not assuming that, but we are just rolling with what we have as given in the statement. Okay. Then we are going to complete all angles here. If we complete, this is 53 degrees. If we complete the angle, I didn't get that well. Take care, Sekhamezi. Take care. I didn't get that well. VMAPs, what didn't you get well? It says if tan 37 is equal to P, determine the following in terms of P. So we need to actually draw and sketch a diagram using the given information so that we can then determine sine of 127. Right, so if we look at tan 37, this angle here is given to us as an acute angle. If you look at your Cartesian plane, this is 0 degrees, this is 90, this is 180, this is 270, this is 360. So the angle 37 degrees is an angle that is located in the first quadrant. It's an acute angle. It's an angle between 0 and 90. So I'm going to sketch a right angle triangle with a terminal arm. All right, 37 degrees, okay, for my terminal arm. Obviously I completed, it's a right angle triangle. That is 90. Then you add 90 plus 37, you get 127, plus 53 gives you 180. Okay, so all of our angles are there, 37 degrees, 53, and 90. Then we use this. Tan 37 is equal to P over 1. Remember this P we write as P over 1. Why do we write it as P over 1? Any number, guys, 4 can be written as 4 over 1. 8 can be written as 8 over 1. P can be written as P over 1. So we say this top variable represents my opposite side. The opposite side to 37 degrees. So 37 degrees, its opposite side is P. And then adjacent side 1. Now we need to find R, which is basically the hypotenuse. In order to find R, guys, what do we use to find R? What do we use as usual to find R? What do we use to find R? V. Marinette. Anyone wants to answer me? What do we use? Olan, Karen, Guicho. What do we use to find R? I'm missing the hypotenuse value. What do we use to find the R? Pythagoras, thank you. Guido United, very good. So we say the square of the hypotenuse side is equal to the sum of the square of the other two sides. Yeah. You forgot the term. Well, you remember it now? Hopefully you remember it now. VMAPs. X, Y, 1 squared is 1. P, the whole thing squared is p squared. We take the square root. On both sides we put a plus minus. But fortunately we know our r value can never be negative. We know our r value can never be negative. So that means r is equal to the square root of 1 plus p squared. So here, we're going to say the square root of 1 plus p squared. Now that we have all sides, we can now come and answer the question here. Sine of 127 degrees. The table is where I used to fumble it. I see it now. The table. What table, Navi Maps? Which table? What table are you talking about? What table, my dear? The table is where you would fumble it. Fumblity, fumblity, fumblity. Okay. So now that we have a complete diagram, it has all the angles and all its accompanying coordinates for x, y, and r. Oh, the 37 degrees are cute. Okay, I hear you. So now we want to answer. Okay, sine 27, 127. So we can say sine of, we can reduce using our co-function values. You can say sine of 180 minus 180 minus what gives you 127? 180 minus what gives us 127? I think Tolan, you need to answer here because you're the one that asked this question. Sine of 180 minus what? Because remember, we want to use our function values to reduce. Yes, Tolan, you see. (180 minus 53 degrees). You see? So we're just expressing this. Okay. Then 180 minus is in which quadrant? It's in the second quadrant. That's the 180 minus quadrant. What is the sign of, what's the sign of sine in the second quadrant? Sine is positive. So then we say sine 180 minus falls away. This is positive sine 53 degrees. Okay, so we've just reduced a obtuse angle to an acute angle, which is relevant for this right angle triangle. Now we can go and say, where is 53 degrees in the diagram? You see the importance of filling in all the angles in our diagram. Had we not filled in all the angles in our diagram, we would not have been able to see, oh, there's 53 degrees. Now I need to ask myself, what is the definition of sine? Okay, it is opposite over hypotenuse. Where is 53 degrees? There it is. All right. So then I read using the diagram, sine of 53. So opposite over hypotenuse, using this angle, the opposite side of this angle is 1. So I say 1 over the hypotenuse, which is what? The square root of 1 plus p squared. Okay, so very important that here we used the reduction formula and applied our function value to reduce an obtuse angle to an acute angle. Remember, obtuse is an angle between 90 and 180. Acute is an angle between 0 and 90. Right, so we reduced our obtuse to acute and then expressed sine 53 degrees in terms of p. There it is, 1 over square root of 1 plus p squared. That is in terms of p. So sine 127 is actually sine 53 degrees, which is 1 over the square root of 1 plus p squared. Okay, are we getting it? Make sense? I think I answered Olani's question now fully. If there's any questions, Olani, that you have, something that's not clear for you, this is the best time to let me know. Right? If you fully answered and the explanation was satisfactory, then I would hope, my dear Olani, you could be one that indicates that you are good and you have understood and you are good and you are clear. Okay? Okay. Then the next one, or the last one, is cos of 74 degrees. Cos of 74 degrees. Cos of 74 degrees, what can you say? Cos of 74 degrees is equal to cos of 2 times 37. So this is a typical what? Double angle. So we can just say cos cos squared 37 minus 1, which is 2 cos 37 squared minus 1. We grab cos 37 is p over 1. Then we square it. So this is like 2 into p over 1 is p applied the square to the p is 2p squared minus 1. This is basically the expression of cos 74 in terms of p. Okay, so this would be bumping it up a level, grade 12, because now we are focusing on double angles and the likes. Alright. This one would be a typical grade 11. Okay, so number 1 is grade 11, but number 2 is grade 12, because we are incorporating our double angles for number 2. So number 1, sine 127 for this particular problem is a typical grade 11, but then number 2, cos 74, there we're applying our double angle to basically simplify and then get the expression in terms of p. Okay. Did that help? Did that help, guys? Drip Slick, Olani, Guijo, VMAPS, Tando. Tando 13, is Tando 13 really still here, or like just here? Maybe slept here. It seems like a lot of people are currently in bed. Olani is one, so you could. Okay, I hope that helps you with that question. Any other? Oh, Tando 13. So that means you are taking in grade 10 or 13. Didn't you say you are doing grade 10? Was it grade 11? Okay. Do you have any particular questions of your own? Grade 11, oh, okay. All right, so that was relevant to you, of course. Maybe not this part, because this is grade 12. You guys are only doing double angles in grade 12 next year, but this part here, this first part, definitely relevant to you. Okay. Okay. Any other sections? Tando, any section you'd like to look at? Kulani is like trigonometry and everything. Okay, Olani, I want to ask you, how would you? This is white. It's actually let's just look at it. The song is like in my mind. The Lerato song is in my mind. It's been, and that crazy beat as well is like in my mind. I don't know why. I think I've been watching crazy videos for quite some time. 985 cos 65 plus cos 85 sine 65. So this is where you need to know your compound angles well, right? This thing does not want anything but your knowledge of compound angles. So hopefully your compound angles you know very well. Golan, you need to know your compound angles well. So on your formula sheet, this would be AB, A, B. So if you look at your formula sheet, what does that remind you of? If you are being specific, whilst looking at your formula sheet, what does that remind you of? Okay, your compound angles, right? Sine A, cos A, sine B. Okay. Sine A, cos A, sine B. So when this is expanded, what is the reduction? Sine of what? A minus B. No, sine of A plus B. Sine of A plus B. Sine A cos B plus cos A sine B is the same as sine A plus B. So we are reducing. A 85, B 65. Then what's 85 plus 65? 85 plus 65, 150. Then, if you reduce sine of 150, 180 minus 30. If you reduce using the function values, 180 plus 180 minus 180 minus 30, then of course 180 minus is the second quadrant. How is sine in the second quadrant? 180 minus is the second quadrant. How is sine in the second quadrant? Okay, let's not forget ASTC. All students take. Yeah, how is sine there? Positive. Very good. Very good, V. Very good, Guijo and Golan. Sine is positive. So you write sine 180 minus falls away. You take the acute angle. Then here in grade 12 and 11, it's fine. You just grab your calculator. You get the answer. Right? In grade 10, our beloved grade 10s know that this is the triangle that they should be using. 1 root 3, 2. Okay. So grade 11s and 12 for special angles, once they get to the acute angle, you can just punch this in your calculator and get the answer, and you write it down here. Grade 10s, on the other hand, need to be in the know-how about your 30-60 special angle triangle. Okay. So that means sine of 60 opposite over hypotenuse. That's a half. That's it. Done. Finished. That's how we do that one. Okay. Tando. Kamawam. Pinky. Drip. We've got Jaden. We've got Ompila. We've got Ompila similar. We've got Drip. We've got Tando. Any questions, guys? Any questions? Any other? Any other questions? Lerato, Tando. Lerato is fair. I don't know why that song is on my mind, but it is. It's occupying my mind. It's living rent free. So, guys, okay, hopefully, Olani, we are good. That answers you. So, in as much as you know how to expand your compound angles, you must also know how to reduce compound angles. Okay? In as much as you know how to expand compound angles, you need to know how to reduce. Maybe you already know that sine A plus B is equal to sine A cos A plus cos A sine B, but you also need to know how to expand. Reduce, sorry. Meaning if you have it written in a certain way, expanded, you need to be able to reduce it. Plus, it helps a lot when you are able to do such things. Okay? Any other questions, guys? Yes, if they are not, you guys are allowing me to go to sleep. Dimple! Hello. If you guys are not having any questions, then you guys are basically saying goodbye, good night. Thank you so much for your help. You really helped us out. You can be released. Yes, I'm still learning and rewriting grade 12. Oh, okay. I see, Polan. I see. Yeah, thank you guys for the likes. Really appreciate it. I see we are at 7.6k likes for the live lesson that we had today. Thank you for the double taps. Thank you for the comments. Thank you for participating, and thank you for just being here and showing up. Yeah, unless you have any other questions. Yeah, well, you're already in bed, VMAP, so I'm sure you are like ready to you are ready to sleep away into Tongoland. Yeah, guys, so I was just, I guess, in the same vein. Okay. Matlatata.